In this video lesson, we are going to study the different identification tests that are used in identifying the different classes of the carbonyl compounds. I'm talking of aldehydes and ketones. Precisely, we will be using 2,4-dinitrophenylhydrazine to dictate the presence of a carbonyl group in aldehyde and a ketone. We will also be using Fehling solution and Tollens reagent to differentiate between aldehyde and the ketone. We will also be using the triiodomethane or the Iodoform test, as well as the oxidation test for aldehydes and ketones. Before continuing with our topic, please like this video and subscribe to our channel. Do not forget to hit the notification bell. Welcome back. We will be starting with the general test to dictate the presence of a carbonyl group using a 2,4-dinitrophenylhydrazine. In this test, we have two carbonyl compounds, the aldehyde and the ketone. And our example for the aldehyde is ethanol. And our example for the ketone is propanone, or the common name is acetone. Now, in this test, when a Brady reagent, that is a reaction where 2,4-dinitrophenylhydrazine is put in a solution of methanol and a concentrated sulfuric acid. When a solution of 2,4-dinitrophenylhydrazine is put in a mixture of methanol and a concentrated sulfuric acid, is added to, let me say, two test tubes. Two test tubes, for instance, I want to use, there are two test tubes here. We have two test tubes. One test tube containing aldehyde, in that case ethanol, and the other test tube is containing a ketone, that is acetone. So when 2,4-dinitrophenylhydrazine is added to these two test tubes, there is a deep orange precipitate that is formed. There is a deep orange precipitate that is formed. Let me say, here I have, let's say, a Brady reagent. Brady's reagent. A Brady reagent where we have 2,4 dinitrophenylhydrazine, in a solution of methanol and concentrated sulfuric acid. Okay, the same thing here. 204 2,4 the nitrophenyl hydrogen in a solution of methanol and concentrated sulfuric acid. Okay, let's say I put this here into a test tube containing what? Into this test tube containing the aldehyde, that is ethanol. I put this in here into this test tube. I also put this here, this Brady's reagent, into this test tube. If I put all this mixture, this Brady reagent, into a test tube containing the ethanol and into a test tube containing the acetone, the result will be a deep orange precipitate that is formed. So the test tube, the color change will be to a deep orange precipitate is formed. A deep orange precipitate is formed. That will be the observation. The observation will be observation. The observation here will be, our observation here will be deep orange precipitate is formed. There will be a deep orange precipitate that is formed. A deep orange precipitate is formed. The same thing here. A deep orange precipitate is formed. A deep orange precipitate is formed. A deep orange precipitate that is formed. And what is the indication of this deep orange precipitate? Observation. This deep orange precipitate, it is indicating the presence of a carbonyl group. It is indicating the presence of the carbonyl group. Shows this is present. The observation is a deep orange precipitate that is formed, showing that this is present. It shows that this group is present. Yeah. This is present. This is present. It also shows here that in the acetone, that the same carbonyl group is present. The same carbonyl group is present. And let me show how the reaction will be taking place. With ethanol, this is what is going to happen. With ethanol, this is the reaction. We will have, let me say we have a CH3 here. This is the reaction. We have this is the reaction that is taking place when ethanol reacts with 2,4-dinitrophenylhydrazine. Uh, there is a condensation reaction. We will have here minus a molecule of water that is formed. And what will be the product? This will be our product here. Oh, sorry. this will be the product that will be formed. And the product will be the name of the product will be acetaldehyde. So that will be the compound that will be formed. Once more, I said we want to use the Brady reagent, which is a 2,4-dinitrophenyl hydrazine in a solution of methanol and a concentrated sulfuric acid. When this Brady's reagent is added to 2 test tubes, one containing ethanol and the other one containing acetone. One containing ethanol and the other one containing acetone. The one that contains ethanol, the observation will be the color will change to a deep orange precipitate. There will be a deep orange precipitate that is formed, indicating the presence of a carbonyl group in this ethanol. In the other test tube containing acetone or propanone, there will also be a deep orange precipitate, also indicating the presence of the carbonyl group there. Now, I am showing the reaction between ethanol and 2,4-dinitrophenyl hydrazine, resulting in acetaldehyde 2,4-dinitrophenyl hydrazine. That is the reaction, and a molecule of water is released. With acetone, this is with aldehyde. This reaction is with aldehyde, that is aldehyde, and our example is ethanol. Now, we want to go to the reaction between ketone, and our example will be acetone. Ketone and our example will be acetone or propanone. In the same way, you will have a reaction that is CH3 we will have with H2N. That's 2,4-dinitro. Okay. Here, as I said, there is a condensation. This is a condensation reaction. Minus a molecule of water. Now our product formed will be for ketone, and the product formed, the name will be acid. The name here will be acetone. You can say acetone or propanone. Let me use acetone. Acetone 2,4 what? Dinitro. The nitro phenyl hydrazone. So we will have this as our product. That is for acetone. We will have acetone 2,4-dinitrophenylhydrazone. That will be the product. That is the product that will be formed in the test tube, giving us a deep orange precipitate. So that is a reaction. And this is the product with aldehyde, acetaldehyde 2,4-dinitrophenylhydrazone 2. That will be the same product that will be formed, giving us a deep orange precipitate in the test tube, as you have observed here. That is how you will see it. Okay, so that is the observation when used 2,4 when you are using Brady's reagent to test the presence of a carbonyl group in aldehyde and ketone. So now we will go into the second test, which will be a Fehling solution. We will go into the second test, a Fehling solution. And I said, regarding a Fehling solution, using a Fehling solution to distinguish between aldehyde and ketones. Aldehyde and ketones. You'll see in Fehling solution, you'll see what happens. We have the aldehyde is there. Our aldehyde, as I said, is ethanol, and the other one is acetone or propanone. When a few drops of Fehling solution, a Fehling solution is a complex. It's a complex containing a copper 2 ion. So now, in this Fehling solution, when a few drops of Fehling solution is added to 2 test tubes containing aldehyde and ketone, for instance, ethanol and propanone, the mixture is warmed gently in a water bath for a few minutes. The blue solution containing the ethanol will do what? The blue solution containing the ethanol will do what? Will, I said the blue solution containing the ethanol will turn red. It will turn red. Red precipitate will be formed. But the blue solution containing acetone, there will be no change. It remains blue. It remains blue. Let me put it here again. Addition of a few drops of Fehling solution. Addition of a few drops of Fehling solution into the test tube here. I said it's a complex. It is blue in color. Fehling solution is blue in color. It's a complex containing copper 2 ion. So you will see that in this case, when Fehling solution is added here, into this solution containing aldehyde, which is ethanol, the color of the blue color here will turn what? It will turn red-orange. It will be red-orange in color. Let me just put it here. Let me say if we put here, if we put it here, this is what we'll get. A red-orange color is a red-orange color precipitate is formed. Formation of red-orange precipitate. Observation. Our observation is formation of red-orange precipitate. Formation of red-orange precipitate. Formation of red-orange precipitate. There's formation of red-orange precipitate. The color will change to what? To red-orange color. A red-orange color is formed. Now, here, the same thing here. And we should add, again, addition of a few drops. Addition of a few drops of Fehling solution. Observation. Our observation is this. Observation. We are addition of a few drops of Fehling solution into the test tube containing acetone. What will happen there? The test tube containing acetone, no reaction. No reaction. The blue color remains. No reaction is observed. The blue color, the blue solution, the blue color remains. The blue color doesn't change. The blue color doesn't change, implying no reaction. Formation of red-orange precipitate, implying a reaction has taken place in the case of aldehyde. So now, no change. Now, we are saying that in the case of aldehyde, in the case of ethanol, what has happened? What has caused the formation of a red-orange precipitate? A reaction has taken place in the case of ethanol. This reaction here, the reaction here shows that copper, the copper ion here is acting as an oxidizing agent to oxidize the aldehyde present here to carboxylate ion and itself reduced to copper 1. A reaction has taken place here. There is a redox reaction that is taking place here. The copper 2 ion is going to oxidize. It's acting as an oxidizing agent and is going to oxidize the aldehyde present here to the carboxylate ion and itself being reduced to copper 1. See what I am talking of? Let me just write an equation so that you can better understand what I am saying. Here, with aldehyde, I say with aldehyde, that is ethanol. With aldehyde, what happens? Let me write the equation for you to see. You will see here that the aldehyde with aldehyde plus we will have plus a CH yeah plus 3 molecules of water. I can say this is ethanol. This is ethanol solution, aqueous solution, and this red precipitate this is the red precipitate, the solid that is being formed. The red precipitate, that's the red precipitate that is being formed. This is the aqueous. This is aqueous. And this is water. So right now, this is the reaction that is taking place there. This is the reaction. I said, what is happening here is that when a few drops of a Fehling solution is added to a test tube containing aldehyde, such as ethanol, and the reaction mixture is warmed gently in a water bath for a few minutes, the blue solution containing ethanol will turn red-orange. It will turn, the color will, the blue solution will turn to be red-orange color precipitate. This is the precipitate that is formed here. This is the precipitate that is formed. That is a copper 1 oxide. That's the precipitate that is formed. A red-orange color precipitate that is being formed. Here, copper is acting as an oxidizing agent. Copper is an oxidizing agent. That is copper 2. Copper 2 is an oxidizing agent. Copper 2 is an oxidizing agent. Oxidizes what? Oxidizes it oxidizes the aldehyde, that is aldehyde, to what? To carboxylate ion. To carboxylate ion. To carboxylate, and itself reduced to copper 1. And itself reduced to copper 1. Carboxylate ion, and is reduced to copper 1. The copper 1 as precipitate. Is reduced to copper 1 as precipitate. It should be noted that the ketone or the propanone is not oxidized, and the ketone, which is the propanone, is not oxidized. That is why the solution remains blue. So that is the reaction. That is the reaction. We will go now to the second test. We are using Fehling solution. The second test now will be using Tollens reagent. We will be using Tollens reagent to distinguish between aldehyde and a ketone. We will be using Tollens reagent to distinguish between aldehyde and a ketone. We will still be using the same example, ethanol and acetone. You will see the results. Now, I said in this our example here, Tollens reagent. Remember a Tollens reagent. A Tollens reagent. This is a complex too. It is a complex. It is a diamine silver 1 ion. It's diamine silver 1 ion. So when a few drops of let me say ethanol, which is the aldehyde, is added to, or let me just say, when a few drops of Tollens reagent, when a few drops of this Tollens reagent here is added to 2 test tubes, 2 test tubes containing what? Containing aldehyde and the ketone, and warm in a water bath for a few minutes again, you will observe that a gray precipitate or a silver mirror coating is seen in the walls of the test tube containing ethanol. I said addition of Tollens reagents. Tollens reagent here. Let me say this is a Tollens reagent here. Tollens reagent. This is ethanol. This is a Tollens reagent. Is a Tollens reagent. What you will find here is that here, when a Tollens reagent, a freshly prepared Tollens reagent is added into a test tube containing ethanol and warmed, this test tube is warmed in a water bath for a few minutes, you will observe some gray precipitate here. Gray precipitate. There will be a gray precipitate. Let me say that here, observation is gray precipitate. Observation here too. There will be what we call a gray precipitate of gray precipitate. A gray precipitate or silver mirror. Or silver mirror coating. A silver mirror coating. Coating on the walls. You will see a gray precipitate or a silver mirror coating on the walls of the test tube in case of aldehyde. When a freshly prepared Tollens reagent is poured into the test tube and warmed in a water bath for a few minutes, a gray precipitate or a silver mirror is a gray precipitate or a silver mirror is observed in the silver mirror coating is observed on the walls of the container. But in the case of acetone, there is no change. The solution remains like that. There is no change. There is no change. Why is there a change in the solution changes to what? To gray precipitate or silver mirror. Why is there a formation of a silver mirror on the walls of the test tube in the case of aldehyde? Let me explain it to you. Let me explain it to you. This is because ethanol reduces the diamine silver 1 ion to metallic silver. It is the metallic silver that appears on the walls of the container or the test tube. So ethanol will reduce the diamine silver 1 ion to metallic silver. Let me just write the equation so that you can better understand. In the case of ethanol, ethanol. That is the aldehyde. In the case of the ethanol, this is what is happening in the case of ethanol. We will have a CH3 I said it is diamine silver 1 ion. So this is the complex. What you will have will be you will have should write, let me say red. You will have the silver plus the silver plus the carboxylate. What is happening here? This is ethanol. Ethanol. This is the diamine silver 1. Diamine silver 1. Oh. The diamine silver 1 ion. Diamine silver 1 ion. Okay. And we will have to heat it gently. This silver here, which is the solid, that's what we call the silver mirror. This is the silver mirror we are seeing here. They are grape, we call them other, that is silver mirror. Diamine. Oh. Silver one. Okay. So that is it. That is the reaction. What you see in this reaction is, what you are saying in this reaction is that because the reaction is taking place in alkaline medium, the reaction is taking place in an alkaline medium. It is usually a carboxylic acid that is being formed. It is usually the carboxylic acid that is being formed. So the carboxylic acid that is being formed is immediately neutralized to what? To the carboxylate. Because the reaction is taking place in an alkaline medium. The carboxylic acid that is being formed here, that is the ethanoic acid that is being formed here, is immediately neutralized. It is immediately neutralized to what? To the carboxylate ion. To the carboxylate ion. Because the hydrogen ion is removed. Because the hydrogen ion on the acid is removed, and a salt is formed. I said because the reaction is taking place in an alkaline medium, the carboxylic acid that is being formed here is immediately neutralized to what? To the carboxylate ion. How is this done? The acid group that is here, the OH that is being here, the hydrogen there is removed. The hydrogen there is removed. The hydrogen in the COOH group here is removed. It is removed, and this salt results, and that is the result of it. So we call this the carboxylate ion. This is the carboxylate ion that is being formed. So that is how the reaction occurs. Now we are going now, but for why there is no reaction when it has to do with acetone or propanone is because here there's no reaction here. There's no reaction at all when it has to do with Tollens reagent. There's no reaction at all. No reaction occurs. And that's why the solution remains like that. Let's go straight away to the third test. The third test is the iodoform test. We can still use the iodoform test to distinguish between aldehyde and ketone. Okay, with this iodoform test, you will see that here this is an aldehyde. The test, all of them, why I say all of them will give a yellow precipitate. The two of them will give a yellow precipitate. The two of them will give a yellow precipitate. Why? The aldehyde test is a test. The iodoform test is a test that is used to identify the presence of a CH. This is used to the presence of a CH, a CH3 CH OH. That is a methyl group and a hydrogen atom on the same carbon atom that bears the functional group. And that is for secondary alcohol. You know, secondary alcohol are oxidized. Secondary alcohol are oxidized to ketone, and ketone will do what? A methyl ketone will give a positive test with iodoform test. So, like in this case, for the iodoform, this will give a yellow precipitate. This reaction will give a yellow precipitate. And this other reaction will also give a yellow precipitate. Let me just explain it here for you to understand. With aldehyde, this is what happened. A CH3, that is aldehyde. Aldehyde, for example, ethanol. Here we have a CH3. In this reaction, this is the reaction. Okay. The first step in this reaction will be what? The first step in this reaction, since in iodoform test, we are doing what? We are reacting the substance with alkaline aqueous iodine. Alkaline aqueous iodine. When we react with alkaline aqueous iodine, there is oxidation that is taking place there. In this case, we will have alkaline aqueous iodine. That is, I said this is iodine plus alkaline aqueous iodine. There is halogenation. In this halogenation, what takes place here is halogenation of the hydrogen atoms here are replaced by the halogen, which is the iodine. We will have this. This is the product that comes here. We have CH, then the triiodomethane, plus the H, when there is a splitting, and you go to our previous video when we're treating alcohols, you will see how secondary alcohol were undergoing at the iodoform reaction. I am just summarizing it here. So now, secondary alcohols are oxidized to what? To ketones. From the ketone, they were splitting. And now we did what we call alkaline hydrolysis. So there is first halogenation, followed by alkaline hydrolysis. So when we did the halogenation, the hydrogen ion were replaced. The hydrogen atom were replaced by the iodine. Secondly, hydrolysis. That is why you see the hydrogen here and the extra oxygen on this other side. So now, when we don't do this, this is what we now call it a yellow precipitate of triiodomethane. Yellow precipitate. This is a yellow precipitate here. With propanone. With propanone, this will be the reaction with propanone, that is ketone, that is propanone, ketone, that is propanone. This is the reaction, halogenation to form an intermediate. And you know this is propanone. We have CH3, CH3 as a halogenation to form an intermediate. When there is this thing here, this is what happens. Sorry. We will have this. We will still have our CH3. I said it is halogenation to form an intermediate. Now, there's hydrolysis of the intermediate. Hydrolysis of the intermediate, this is an intermediate. Hydrolysis of intermediate now comes in. We will have CH3. There is hydrolysis to take place. And what will form? During the hydrolysis, what is happening? This is what happened here. CH3. CHI3. This is alkaline hydrolysis. Aqueous alkaline hydrolysis. Sorry. And in the other case, this is halogenation. Here I said it is here it was halogenation. Now, and we now form, this is our triiodomethane. Triiodomethane yellow precipitate. This is the salt. And this is our triiodomethane yellow precipitate. This is our triiodomethane yellow precipitate. I said this test can be used to identify the presence of the secondary alcohol group. So that is how, so we now say the two test tube, this will give a yellow precipitate, this will give a yellow precipitate of this. This is HI3, which is a yellow precipitate. And this will also give CHI3, which is also a yellow precipitate. So the two will give a yellow precipitate when reacted with this reagent. When the two undergo a iodoform test, they will form a yellow precipitate. Yellow precipitate in the case of aldehyde, and yellow precipitate in the case of propanone. Now, the last test is the one involving the one involving using acidified potassium dichromate 6. Acidified potassium dichromate 6. Heating these two compounds, aldehyde and acetone. Under reflux, what you will observe is with ethanol, the observation with ethanol will be is that the color of the solution will change from orange to green. Orange observation. The color will be orange using acidified potassium dichromate 6. The color will be from orange to green. Will be from orange to green, indicating that what? The orange dichromate precipitate is reduced from +6 to what? To +3. So this is an oxidation reaction. Acidified potassium dichromate 6 is a good oxidizing agent. It's going to oxidize the aldehyde. It's now going to oxidize the aldehyde now to the corresponding carboxylic acid. And the color is going to change from orange to green, indicating that the orange dichromate precipitate is reduced from +6 to +3 ions. With acetone, our observation, no color change. No color change. No color change and no reaction. No color change and no reaction. So we can now conclude that only aldehyde can be oxidized by this oxidizing agent. Aldehydes are further oxidized to carboxylic acid. Aldehyde can be oxidized by using acidified potassium dichromate 6 to carboxylic acid. And the color will change from orange to green, indicating that the orange dichromate precipitate is reduced from +6 to +3 ion. With ketone, there is no reaction. With ketone, no reaction takes place and the color will still remain. The orange color will still remain there. So that is what will be observed here. So, fellow learners, if you haven't subscribed to our channel, please subscribe and hit the notification bell. Thank you for watching.